students, welcome to Maths with Panindra. In this video, one example problem from circles we are going to discuss now. Find the equation of circles which touch 2x minus 3y plus 1 equal to 0 at 1, 1 and having the radius root 13. So according to the question, this is the way we have to draw the figure. See here, find the equation of circles which touch 2x minus 3y plus 1 equal to 0. So this is the line 2x minus 3y plus 1 equal to 0, which touches the circles at 1, 1 having the radius root 13. We don't know the centers of the required circles. This is one circle center, this is another circle center. The requirement is need to calculate the centers of those circles. That centers we are assuming that h comma k, either this one or this one. So how to get these centers? By using the given data. Observe carefully, the line of center C1, C2 is absolutely perpendicular to the given line. Both are perpendicular. Absolutely perpendicular. So first given line in the solution step, find the equation of circles they are saying now. Let the centers of the required circles, be x1, y1. x1, y1 I am assuming that either this one or this one. And given radius r is equal to root 13. Second step, circles touch at P of 1, 1 with the line 2x minus 3y plus 1 equal to 0. So this information from the given question only we need to write. Line of centers is perpendicular to, before that, the perpendicular line we can calculate. Line of centers, that means C1, C2 is perpendicular to 2x minus 3y plus 1 equal to 0. Then its equation is, and passing through also, and passing through one comma 1. So perpendicular line we want to calculate, that only C1, C2. Perpendicular line for this equation. So the slope of this equation is what? M is equal to minus x coefficient by y coefficient. So M is equal to 2 by 3. Perpendicular slope means what? Minus 1 by m. Perpendicular. Observe carefully, dear students. So perpendicular slope minus 1 by m. So m value is there, directly minus 1 by m. And passing through which point? 1, 1. So line of centers equation. Equation of C1, C2. Y minus y1 equal to minus 1 by m into x minus x1. For understanding purpose, clearly I am writing, otherwise directly also we can write. Y minus 1 equal to minus 1 by 2 by 3 into x minus 1, denominator numerator. So y minus 1 is equal to minus 3 by 2 into x minus 1. So cross multiply 2y minus 2 is equal to minus 3x plus 3. So these values I am taking here, it will becomes 3x plus 2y minus 2 minus 3 minus 5 equal to 0. This is line of centers C1 C2, equation of C1 C2. Equation of C1 C2 is. So what for you are calculating equation of C1 C2? So equation of C1 C2 we got it now. To calculate the centers of this line, go to the straight line topic. This is interlinked with straight lines also. The points which are lying on the line at a distance of root 13, r is equal to root 13 here, radius of the circle. So by using parametric equation, we require the theta value. So from this equation, tan theta you can calculate. Slope of this line, slope of C1 C2, slope of C1 C2, m is equal to tan theta. M value means what? Minus x coefficient by y coefficient. So minus 3 by 2. We have to consider only C1 C2 slope only, not for this given equation. Why? Because the points which are lying on the line we are calculating. So tan theta is minus 3 by 2. Like this rough figure we have to draw that. This is the theta. Tan theta definition is what? Opposite by adjacent side. So if you are taking like this is negative side now, minus 3 by 2 is there. So this is positive y-axis, we can write as only plus 3, here minus 2. And here root of 9 plus 4 root 13. From this sin theta cos theta calculate. Sin theta is equal to opposite by hypotenuse 3 by root 13. And cos theta equal to minus 2 by root 13. Yeah, done here. What is the use of calculating sin theta cos theta? By using parametric equations, the third step. By using parametric equation of the straight line. Line of C1 C2 is straight line here, or x comma y is equal to x1 plus or minus r cos theta, y1 plus or minus r sin theta. So in this you can replace what is x1 y1 means this point only x1 y1 we can take it. This is x1 y1. Here center I have taken x1 y1 generally. So which is equal to x1 1 plus or minus r value root 13, cos theta value minus 2 by root 13, y1 plus or minus r value root 13, sin theta value 3 by root 13. So root 13 cancel here, root 13 get cancel, which is equal to 1 plus or minus minus 2, 1 plus or minus 3. So come to the cases. X comma y is equal to, if we consider 1 plus minus 2, 1 minus plus 2, comma 1 plus or minus 3. So first here minus, here plus, if we consider 1 point will come 1 minus 2, comma 1 plus 3, and 1 plus 2 comma 1 minus 3, which is equal to minus 1 comma 4 and 3 comma minus 2. These are the centers of the required circles. So case 1, case 2. So center, first circle center I am taking here, center C is equal to minus 1 comma 4. And radius is given already root 13. We know that the equation of circle with center h comma k radius r is the required circle x minus h whole square plus y minus k whole square is equal to r square. Am I right? So x minus of minus 1, x plus 1 whole square, y minus 4 whole square is equal to root 13 whole square. So expansion x square plus 2x plus 1 plus y square minus 8y plus 16 That root 13 whole square we can take this side minus 13 equal to 0. So x square plus y square plus 2x minus 8y, 17 minus 13, so plus 14 is equal to 0, which is one of the circles. Come to the case 2. In the case 2, here we can write it as minus 1 comma 4, another one is 3 comma minus 2. Center C is equal to 3 comma minus 2 and radius R is equal to root 13. Second case, the required circle x minus h whole square plus y minus k whole square is equal to r square. Substitute x minus h value is, this is h, this is k. X minus 3 whole square plus y minus of minus 2 plus 2 whole square is equal to root 13 whole square. So x square minus 6x plus 9, y square plus 4y plus 4 minus 13 equal to 0. Minus 13, 9 plus 4, 13 cancel. So x square plus y square minus 6x plus 4y is equal to 0, which is the required circles. Therefore, the required equation of circles are x square plus y square plus 2x minus 8y plus 14 equal to 0 and x square plus y square minus 6x plus 4y equal to 0. Thank you, dear students. One of the students requested to do these some 2-3 example problems. That's why I'm separately making these videos. Yeah, this is also one of the important questions from the circles, dear students. If the chord of contact of P of x1, y1 with respect to x square plus y square equal to a square, cut the circle at A and B such that angle AOB is equal to 90 degrees. Then show that P lies on the circle x square plus y square equal to 2a square. See here, the figure will come like this, dear students. This is the circle equation. Here the point is P of x1, y1. The chord of contact is this one. This is chord of contact of S is equal to 0. Chord of contact is also S1 equal to 0 formula. Chord of contact definition is what? The line joining of point of contacts of whose tangents from the point P. See, this is tangent from the point P. This is also another tangent at the point P. So where these points are line joining, this is A, this is P. That is the reason if the chord of contact of P with respect to this circle, this is x square plus y square is equal to a square, which cuts the circle in two different points A and B, such that here the condition is giving, this is O. So here it is making an angle 90 degrees. That's what they said. So here one locus it will form. That locus is what? That locus we have to prove x square plus y square equal to 2a square. So according to the figure, you write the steps, proper steps. First, the chord of contact, first given circle, x square plus y square is equal to a square. Put that equation number 1. Next step, the chord of contact of point P with respect to equation 1. The chord of contact of P with respect to equation 1 is, the chord of contact of P with respect to equation 1 is S1 equal to 0, that is xx1 plus yy1 is equal to a square. This chord of contact, this equation cuts the circle in two different points, equation 2, and making an angle 90 degrees. Angle AOB they mentioned as 90 degrees, where O is the center of circle. So whenever they are making an angle, this line cuts the curve. Line cuts the curve means go to the first here, homogenizing you can apply. So second equation, it is in the form of Lx plus My plus n. To homogenize this value you can make as 1. So xx1 plus yy1 divided by a square is equal to 1. So homogenizing equation 1 with the help of equation 2. That is what the chord of contact cuts the curve into different points. Since equation 2 cuts equation 1 in A and B in brackets by homogenizing equation 1 with the help of equation 2 is, so homogenizing by writing x square plus y square, wherever constant is there, x term is there into 1, y term is there into 1, constant is there into 1 square, is equal to a square, this is the constant, into 1 square. In place of 1, substitute this value. So x square plus y square is equal to a square into xx1 plus yy1 by a square whole square. So x square plus y square is equal to a square into xx1 plus yy1 whole square by a power 4. So a square whole square, one of the a square will be cancelled, a square we can take here, a square into x square plus y square is equal to a plus b whole square expansion, x square x1 square plus y square y1 square plus 2xy into x1 y1. So all these values we can take here, a square x square plus a square y square minus x square x1 square minus y square y1 square, and this value also minus 2xy into x1 y1 is equal to 0. From these two, a square, from these, sorry, x square, from these two, y square. If we take out common, here on we'll write one more step. So a square minus x1 square into x square plus xy into minus 2x1 y1 plus a square minus y1 square into y square is equal to 0. So once again I am writing a square minus x1 square into x square plus xy into minus 2x1 y1 plus a square minus y1 square into y square equal to 0. This represents the combination of OA and OB lines. Since angle AOB is equal to 90 degrees, then in the first year, when the pair of lines are perpendicular, OA and OB, this represents, it represents OA and OB lines. That means combination of lines, pair of lines. To understand, we write it. No, not compulsory to write. So since angle AOB is 90 degrees, then coefficient of x square first here plus coefficient of y square is equal to 0. Coefficient of x square plus coefficient of y square equal to 0. So what is coefficient of x square? A plus b equal to 0 generally. So here a is equal to, compare with ax square plus 2hx square plus by square. So a square minus x1 square plus a square minus y1 square is equal to 0. So a square plus a square, 2a square minus x1 square y1 square, you can take this side, plus x1 square plus y1 square. So they are asking that show that P lies on the circle. Look, so that means indirectly they are asking locus. Therefore the locus of point P is, therefore the locus of point P is x square plus y square is equal to 2a square. Hence the result. Thank you, dear students. Yeah, hi dear students. Welcome to our channel. One more important question from the circles. If the polar of points on the circle x square plus y square equal to a square with respect to x square plus y square equal to b square touches the circle x square plus y square equal to c square, then show that A, B, C are in geometrical progression. A, B, C are in geometrical progression. So how to do that? It's very easy. By observing all the circles having the same center. That means concentric circles. See here, the figure will come like this. So first circle, it will come like this. Second circle, next third circle, so for all center will be same. Center 0, 0 only for all the circles. According to the question, this is the first circle. X square plus y square is equal to a square. Second circle equation is, here I am writing, this is x square plus y square is equal to b square. And third circle, here I am writing x square plus y square is equal to c square. If the polar of points on the circle, so you have to consider one point. Here I am considering one point p of x1 comma y1. First step, let p of x1 comma y1 be any point on the circle x square plus y square is equal to a square. Keep that equation number 1. Then, so in place of x comma y, the point lies on the circle now. It will becomes x1 square plus y1 square is equal to a square. Put it in box. This result we will use in the coming steps. This is the first step completed. So if the polar of points on the circle, point we assume that point is there, circle will be here. The polar of that point P with respect to second circle. So polar equation. So observe carefully here. This is a polar of point, polar of P with respect to second circle. S1 equal to 0 with respect to x square plus y square equal to b square is. So we know that S1 equal to 0, polar equation. X1 plus y1 plus g index plus x1. So with respect to this circle, x square plus y square equal to b square, no? Next step that only. The polar of P with respect to x square plus y square is equal to b square is. This is S is equal to 0 circle. Is S1 equal to 0. That is S1 equal to 0 according to this circle you have to write, dear students. So x1 plus y1, that constant g value of value not there. So that constant b square we can take this side, means minus b square equal to 0. Keep it as equation number 2. xx1, it is in the form of ax plus by. So x1 into x plus y into y1 plus minus b square is equal to 0. This polar equation touching the third circle. Next step, equation 2 touches equation 3. Otherwise, write clearly, equation 2 touches the circle. X square plus y square is equal to c square, third circle. Then any line touching the circle, radius of the particular circle is equal to perpendicular distance from center of the circle to this line. Then radius of equation 3 is equal to perpendicular distance from center of the circle, from third circle center only can take, from center of equation 3 to equation 2. So radius of equation 3 is what? X square plus y square equal to, it is in the form of r square, and you know r is equal to c. So radius of this equation 3 is c. Perpendicular distance from center of the circle to, from perpendicular circle, what? Center here 0, 0. So perpendicular distance from origin to the line is always, here I am giving formula, perpendicular distance from origin to the line ax plus by plus c is equal to 0 is d is equal to mod c by root of a square plus b square. You have to remember, dear students, 0, 0 is what? Center of this circle. So mod c by root of a square plus b square. In this, compared with ax plus by plus c, mod c is what here? Mod minus b square by root of a square. Compared with ax plus by, a value is what? X1 square plus b square, y1 square. C is equal to mod minus b square is plus b square by root over x1 square plus y1 square value is what? A square. Root square cancel. It will becomes a. So c is equal to b square by a. So cross multiplication, AC is equal to b square. Therefore, b square is equal to AC. That is a comma b comma c are in geometrical progression. They are asking to prove ABC or in GP. That's what we proved here. I hope you understand, dear students. This is the way the diagram, if you draw, easy to understand. Thank you for watching our channel. If you like this video, please share to your friends. Yeah. Another important question, dear students, from the circles, examples. Find the locus of midpoints of the chords of contact of x square plus y square equal to a square from the points lying on the line. So first, midpoints of the chords. First, given circle. First step is given circle. X square plus y square is equal to a square. We put that equation number 1. The rough figure, it may comes like this. This is the chord equation. Midpoint of chords x1, y1. What is the formula for midpoint of chords with respect to the circle? S is equal to 0. The midpoint of chords, the midpoints of chords of P with respect to equation 1 is S1 is equal to S11. This equation is S1 equal to S11. So S1 for this xx1 plus yy1 minus a square is equal to s double 1 for this x1 square plus y1 square minus a square. Both sides minus a square is going to get cancelled, and x1 plus y1 minus of x1 square plus y1 square is equal to 0. You put that equation number 2. Next, the locus of midpoints of chord of contacts from the points lying on that line. So indirectly this point is for the required locus, this point is a pole. So the pole of this line with respect to this circle is lying on this line. So you have to imagine that figure, dear students. This is the point we have taken over here, midpoint of chords. So for the required circle, this point is a pole. So that means it may be, the circle may be like this. So the pole of this line with respect to this circle. Before that, I will write one important formula. The pole of this line, in the previous classes we discussed, the pole of Lx plus my plus n is equal to 0 with respect to x square plus y square is equal to r square is minus lr square by n comma minus mr square by n. So by using this formula, this is the important formula. Why we are taking that pole means this point is for the required circle, it is a pole. So that's why the pole of the line means equation 2. Compare with Lx plus my plus n. Here only I am writing. Compare with Lx plus my means here L is equal to x1, m is equal to y1, n is equal to minus of x1 square plus y1 square. The pole of the line equation 2 with respect to equation 1. With respect to equation 1 is, so write formula x comma y is equal to minus lr square minus L value is what? x1, r square is a square here, by n value is what? Minus of x1 square plus y1 square, comma minus mr square minus m value is y1 into a square by minus x1 square plus y1 square. So here minus get cancelled. We will get it as a square x1 by x1 square plus y1 square, comma a square y1 by x1 square plus y1 square. This pole lies on the line. That only they said, from the points lying on the line. So this x comma y, since the point x comma y, since the point x comma y lying on the line Lx plus my plus n is equal to 0, then we have, so wherever x comma y is there, you have to replace with these values. L into a square x1 by x1 square plus y1 square plus m into a square y1 by x1 square plus y1 square plus n is equal to 0. So take LCM here. x1 square plus y1 square LCM. So a square x1 into L plus a square y1 into m plus n into x1 square plus y1 square is equal to 0. So cross multiply, and from these two a square take common, lx1 plus my1 plus n into x1 square plus y1 square is equal to 0. Therefore, the locus of point P, so wherever x1, y1 is there, replace with x comma y. a square into lx plus my plus m into x square plus y square is equal to 0. This is the way we can give the answer, dear students. They are asking to find the locus, means this is the required locus. The point we assume that the locus point. I hope you understand. We'll take that another example in another video. Thank you.